Okay, here we have a third question about these random variables, these combinatorial ones. And we now have a coin that's biased, so the probability of heads coming up is 1/3. Let me write that a bit more neatly. 1/3. It's flipped 5 times and the number of heads is called x. And we're asked to complete the tables below and then find the expected value of the variance as usual. So again, please pause the video and have a go at that. Okay, so let's find the probability that there are no heads. Well, we have a now familiar tactic here. We're thinking we've got to come up with tails 5 times in a row, so that will be probability that x equals 0 will actually be 2/3. That's the chance of not getting ahead to the power of 5. Okay, I'll work that out. That's 32 over 243. Okay, so that's that. Probability that x equals 1, well, there are a number of ways it could happen. The heads could result in the first, second, third, fourth or fifth flip. There are 5 orders it can happen in, and the way that we're thinking about that is we're thinking there are 5 coin tosses, we must choose one of them to be heads. 5 choose 1, and now how likely is each of those 5 options? Well, in any of those specific options you've got to have tails coming up in 4 specific places, that's 2/3 to the 4th, and heads coming up in 1 specific place. So that's 1/3 to the 1 times 2/3 to the 4th. So all of that comes out as 80 over 243. So I'll put that in as well. Okay, we'll talk about the second row of this table in a second. The probability that x is 2 is very similar. We need to choose 2 of the 5 available slots to put a heads in. How many ways can I do that? That is 5 choose 2. Probability that x equals 2 is 5 choose 2 times, then in each of the 2 specific slots the heads needs to come up, that's 1/3 squared, and then the tails needs to come up in the other 3 slots. Sorry, that should be 2/3 cubed. Now, if you've temporarily forgotten how to calculate 5 choose 2, another way of thinking about that is that's the number of anagrams of this word. Okay, it equals number of anagrams. There, which is 5 factorial over 2 factorial, 3 factorial for the repeats, which is 5 times 4 over 2 times 1, which is 10. Okay, it's the 10 that we're going to use. So that's how you calculate those choosing numbers. And again, it fits very nicely with this context. So the probability that you end up with is, it actually turns out to be 10 times a 9th times 8/27, which is, again, interestingly enough, 80 over 243. It's sort of a strange coincidence that these are the same. Their 80s come from different reasons, so they won't always be the same. Okay, we can now hopefully speed up and fill in the rest. So the probability that x equals 3, let's just change a few of these. It'll be 5 choose 3 ways of choosing them. That will actually still be 10. But x equals 3. 5 choose 3, still 10 because it's the same as 5 choose 2. But know that we've got to choose the heads have got to come up in 3 specific places. So 1/3 cubed, 2/3 squared, and that actually gives you 40 over 243. Put that in. Probability that x equals 4 is 5 choose 4 ways to choose where the heads come. That's actually just the number 5. 1/3 to the 4 times 2/3 to the 1, and that comes out to be 10 over 243. Finally, the probability you get heads every time in a row is just 1/3 to the 5, which is 1 over 243. And we can do a quick check on an answer like this that these numbers do add up to 1. Okay, so that's called the probability distribution of x. But we're also supposed to count this bottom row, the probability that capital X is less than or equal to x. This is called the cumulative distribution of x. It's a phrase you have to know about. So the chance that x is at most 0 is 32 over 243. The chance it's at most 1 is you just add the two preceding numbers together. 112 over 243. The chance that x is at most 2, less than or equal to 2, is 192 over 243, then 232 over 243, adding 10 over 243 to that gives you 242 over 243, and then just at the end you get 1, which is very reassuring. That shows we haven't made a mistake. All the probabilities do add up to 1. Okay. Now I'll just mention these cumulative distributions, the thing I've written in green, are very, very useful. And in particular, if someone tells you the cumulative distribution, it's quite easy to work out the density, the probability distribution from it, just by subtracting adjacent terms in the list. So the green line there, in a certain sense, gives you all of the information about this random variable, just like the blue line does. If x, I won't even quote the formula, we'll just rush straight in. I'm going to take out a common factor of 1 over 243 right at the beginning, and then do the values times the probabilities. I get 0 plus 80 times 1 plus 80 times 2 is 160 plus 40 times 3 is 120 plus 40 plus 5. Okay. That is 80 plus 60, 160 is 240, 360, 405. 405 over 243. That does actually simplify. We can divide everything by, well, certainly by 3, so let's do that. 135 over 81. We can actually go one step further. We can divide that by 3 as well. 45 over 27. We can divide by 9 here, actually, which is 5 over 3. Now again, I hope that this simplified answer doesn't sort of shock us too much. We had 5 attempts, and each of them had a 1/3 chance of success. So it shouldn't be too surprising that the expected or average number of successes, where a success is coming up heads, is 5/3. Okay? And finally onto the variance, in blue again. So here I need to square the values and multiply them by their probabilities. Again, I will take some shortcuts here. I'll take out a common factor of 1 over 243. 0 squared times 32 is still 0. 1 squared times 80 is still 80. I'll write it as 1 squared times 80. Plus 4 times 80. Plus 9 times 40. Plus 16 times 10. Plus 25 times 1. And then I mustn't forget to subtract off 5/3 all squared. Okay. So that's equal to 1 over 243. I'll do it slowly. 80 plus 320 plus 360 plus 160 plus 25 minus 25 over 9. And if I multiply top and bottom there by 27, I'll get the common denominator of 243. 25 times 27 is 675. So I get 675 over 243. Okay. Now I need to do the adding up. So all over 243. I've got 400 in the first two, 760, 860 plus 60 is 920. 945 minus 675 over 243, which equals, I guess that's 270, so there we go, 270 over 243, and we can actually divide a lot through here. That's actually, we can divide by 27, and get 10 over 9. Okay, so the expected value is 5/3, and the variance is 10 over 9.